All right, so what's section 9.3? Okay. So the first thing we're going to do, we're going to do this like we've done the last few times. We'll come up with a definition. What do we mean by a rotation? What is it telling us? And then we'll do a few rotations. Rotations are pretty easy. Rotation. When we're talking about rotation, since we're going in a circle, we're going to be talking about angles. So we're going to say a rotation of x degrees. And we need to rotate about some point or around some point. So we usually say about. So some point Q, and we call Q the center of rotation. So we always have some kind of center for our rotation. Is a rigid transformation. So rotation doesn't change the size or the shape of our object. It just moves it around. Where a couple of things happen. Just like with reflections. Q, the center of rotation, is its own image. So we say Q equals Q prime. So if we have a point that's on the center of rotation and we rotate it, the center doesn't move anywhere. And then all the other points rotate through the same angle. So all the other points rotate x degrees, and they stay the same distance away from the center. So as we rotate, the things aren't moving further or closer as we rotate, they're rotating around our center. So let's draw a picture and take a look at what this is telling us. So here's our point Q. And we have some triangle here that we're going to rotate. So I'll draw a little triangle. So this is going to be triangle ABC. So when we rotate, we need to be able to measure how far we rotate. So I'm going to draw a little line to one vertex. If we rotate a certain angle, rotate, say, x degrees. And our new triangle is then going to be, so let me do that in a different color. Our new triangle is going to be down here. I'll change the pen color. There we go. And I know my drawing's not perfect, but that would be A prime, B prime, and C prime. So our triangle just rotates down this way. We call X is called the angle of rotation. So we could say it rotates, our angle of rotation is 27 degrees or whatever. And when we say all the points stay the same distance from the center, if we draw this segment from the vertex, or from the center to a vertex of the triangle, after it rotates, that is going to be the same distance. And if we drew a segment to any of the vertices, after we rotated, the distance from the center to that vertex would be the same. So it's not moving further or closer away from the center, just rotating around the center. And we write this is written rotation, small r for rotation, of x degrees about point Q of triangle ABC equals triangle A prime B prime C prime. So for a rotation, we use a small r. For a reflection, we use a capital R. The rotation is going to say x degrees, and it'll tell what our center of rotation is. Further? You good? Okay. And again, rotations are rigid motions. So this triangle would be congruent to this triangle. Triangle ABC would be congruent to triangle ABC. A prime, B prime, C prime. So all the lengths are the same, all the angles are the same. So that's our third rigid motion. So our rigid motions are translation, reflection, rotation. All right, so if we wanted to draw the image of a rotation of 100 degrees about point C of triangle LMN, and I'll draw a picture here in just a second. So this might be something that you'll do in your project. So your project, one of the things you're going to do is rotate your image. So here's point C. And instead of triangle LMN, why don't we make it a little easier and we'll do segment LM. So we'll just rotate a segment instead of the entire triangle. There's point C. And here is segment LM. And we want to rotate that 100 degrees about point C. So in order to do that, here's what I'm going to do to rotate this 100 degrees. I'm going to draw a line to point L from the center. And then I'm going to get my protractor and I'm going to measure a 100-degree angle around point C. So there's, got it on the line there, and I'm going to, there's 100 degrees, so right there. So I'm going to make a mark here, and then I'm going to draw a new line through that mark. So that makes sure I rotated 100 degrees. And my new point has to be the same distance from C as L. So I'm going to grab my ruler to do that. There's my ruler. And I'm going to measure the distance from L to C. Looks like it's about 2.5 inches. No, 2.25 inches, sorry. And I'm going to make sure my new point is the same distance. So there we go. And there's where my point is going to go, 2.25 inches right there. So right there, and that's going to be my new point, L prime. And then I'm going to do the same thing for M prime. So I'll draw my line a different color. Rotate that 100 degrees. So I'm putting my protractor there, grab that, so I get 100 degrees. There we go. There's where my 100-degree mark is. So I'll put a dot there. Draw another line through that dot. And I have to make sure that M prime is the same distance from C. So I'll use my ruler to measure. And it looks like it's about 2¼ inches also. So I'll rotate around. Draw my new point here. So there's M prime. And I can connect those two and I get segment L prime, M prime. And if I measured L prime, M prime would be the same length as LM, and each point would be rotated 100 degrees. Questions about what we did there? Now if you had to do a really complicated figure, that would be pretty tedious, right? Yeah. There are some special angles where the rotations have nice simple rules that we can use to figure out a new coordinate, so we don't have to measure everything. Yes? What I said was there's some special angles that if we rotate through these special angles, there's some rules that we can use and we don't have to measure every single time. So when you do your project, you're going to want to rotate through those special angles that we'll talk about in just a second. No, you get to choose. You get to choose the angle that you rotate. So that makes it nice. Okay. No, not in your project. If we rotate through certain angles, then we have simple rules that we can figure out our new coordinates. Okay? All right. So in the book, our rotations are always counterclockwise. So I'll say CCW for counterclockwise. So when the book says a rotation, it's always talking about a rotation counterclockwise. And we're going to list some rules for rotations of 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So we have some nice simple rules. A rotation of 90 degrees about, and when I write this O, I mean the origin. So we're rotating about 0, 0. Rotation of 90 degrees about the origin of x, y equals negative y, x. We change the sign on the y and switch places. Change the sign on the y, switch them around, and then we get our new coordinate. So if you decide to rotate your figure in your project by 90 degrees, this is how you would figure out your new coordinate. You wouldn't have to use your protractor and measure. Saves a lot of work. Rotation of 180 degrees about the origin Got that? That's what the O means there. Of our point xy equals negative x, negative y. Change the sign on both. So if you decide to rotate your figure in your project 180 degrees around 0, 0, to get your new points, all you need to do is change your x and your y. A rotation of 270 degrees about the origin of a point xy equals y negative x. So we're going to change the sign on the x and then switch. So if we want to rotate 270 degrees around the origin, change the sign on the x and then switch the places. And then I think we can all figure this one out. Rotation of 360 degrees about the origin of a point xy. What's that going to do to our point? Nothing. Get back to the same place.
Can we do that?
In your project, you have to actually do a rotation where it changes the shape. No change. So these rules, this is a lot easier than measuring them. But if you wanted to rotate your figure 129 degrees, then you have to do what we did with the segments, with all the measuring. All right, so let's look at an example using one of these rules, and I'll show you how easy it is to do these rotations, and then we'll be done. We'll know all about rotations. So we want a triangle ABC, and we have vertices A is the point 1, 1, B is the point 4, 2, and C is the point 0, 4. We want to find the vertices of this rotation. All right, so what are we doing to our figure here? Rotating it 90 degrees counterclockwise about the origin. So for 90 degree rotation, what do? Change sign on y and then switch. So A prime is going to be negative 1, 1. So I change the sign on this and then switch their places. B prime is going to be negative 2, 4. And C prime is going to be negative 4, 0. And if we graph this triangle and graph this triangle, we would see that this is a rotation counterclockwise 90 degrees about the origin. So in your project, I'd recommend you do a 90 degree, 180 degree, or 270 degree rotation. Makes it really easy to come up with your new coordinates. What's that? Then you change it to positive. You just change the sign.
Would the origin, can that be something different?
If it's a different point, then you're back to doing like we did where we had to measure and all that kind of thing. So when you have it the origin and you have the 90, 180, 270, makes it nice and easy. Okay?
How do you know the origin?
It would say, here it says the origin. And in your project, you just choose, I'm going to rotate around the origin. All right, questions? Thank you. All right, our homework. All right, that's it.